All right, my people, let's go over PS Week 5 for pre-calculus. Okay, I am debating whether I want to go over this first section or not, but I will. And please don't miss this. 5 minus 3 over 2 minus 1, 2 minus 0 over 0 minus 0, and 0 minus 0 over 2 minus 0. I will leave the simplification for you, except I do want to let you know that one has an undefined slope. All right, next up, we have a line, 4y equal 2x plus 5. We should put it into slope-intercept form first, which I just did by dividing both sides by 4. So that gives me 1/2 x. So for the line parallel, a parallel slope is going to be the exact same slope. The perpendicular slope is going to be the opposite reciprocal. All right, now I just use either point slope or, slope-intercept form. Let's try that. Y equals mx plus b with this point and this slope, for example. Y equals negative, 5 equals negative 2, that's my slope, times my x value, plus my b, because I don't know what my b value is just yet. That's why I'm doing this, and you can see that b is 11. So this one's negative 2x plus 11. You're going to solve this one very similarly. You can check the key for the correct answer. All right, average rate of change is f of b minus, I'll do it up there, f of b minus f of a all over b minus a. So first I need to evaluate the function at 5. That's 2 times 5 cubed plus 5 plus 4. That's 125. That's 250. It looks like 259. So I got 259 minus the function evaluated at 2. That's 8, 16, 18, 22. And that's all over 5 minus 2. Landscaping company charges $45 per cubic meter plus a delivery charge of $20. There we go. Every cubic yard is $45, and our, this is going to be cost, so you can put C of X if you want to. $45 per square foot plus an additional $20 delivery fee. Up next, we got this little pizza special. So it's $4 a pizza plus a $250 delivery per order. And then on weekends, they have game day. If you order 6 or more, you're only $5 each with no delivery charge. Let's write a piecewise function for this. Okay, so we can see that our cutoff is at 6. So whenever x is greater than or equal to 6, it's $5 each. Whenever x is less than 6, it's $4 a pizza plus $2.50 delivery fee. And here we go, this one. So we're going to start with listing out what we know. We know the distance is 6. We know one of the points is 2, 2, and we know another point is x, 2x plus 1. So we are going to put all this into the distance formula like we did in class. So I'll put 6 there, square root x minus 2 squared plus 2x plus 1 minus 2 squared. Then I will square both sides. That's 36 equal to x minus 2 squared plus 2x minus 1 squared. Now I will expand everything here. That's x squared minus 4x plus 4, and that's 4x squared minus 4x plus 1. Negative 2x, yeah, perfect. Okay, then I'll combine my like terms. Looks like I have 5x squared. I have negative 8x, and I have plus 5, and then I'll subtract 36 from both sides. And that gives me 5x squared minus 8x minus 31 is equal to 0. Okay, I found the quadratic. Now I need to solve that. You have a couple options. You can complete the square. Probably going to use the quadratic formula, though. It's x equals opposite of b plus or minus b squared minus 4ac all over 2a. So plug and chug that, and the solution for this is on the key, so you can check it out. Solving each absolute value equation. All right, we start off by isolating the absolute value, and then we split it into the two equations that we get. X plus 2 is 4, x plus 2 is negative 4. That gives me an x value of 2. This gives me an x value of negative 6. I don't need to check my answers because there's no x value over there. Next up, I'll subtract 4 from both sides, and then I'll divide both sides by 2, and I end up with this, x over 2. Because I have a variable over here, I want to make sure that my outputs are going to be positive when I solve this equation, so I'll have to check for extraneous solutions. 2x minus 3 equals negative x over 2. Okay. I'll subtract x over 2, that's 3 over 2x equal to 3, and I'll multiply both sides by 2/3. 2/3, which is 6 over 3, which gives me an x value of 2. And then over here, I'll add 1/2 x, which now gives me 5 over 2x equal to 3. I'll multiply both sides by 2/5, and that gives me x equal to 6/5. Both of those are going to be good, so I don't have to worry about extraneous solutions. And then finally on the last one, I have absolute value of x plus 2 is equal to the absolute value of x. That's going to give me two equations. X plus 2 is equal to x. X plus 2 is equal to negative x. That gives me 2x equals negative 2. X is negative 1. And then this one gives me a non-true statement. 2 is equal to 0. So we only accept negative 1 as the solution, and we call the other solution extraneous. So there's absolute value equations. Now we want to describe transformations and make sure we list the x and y intercepts. All right, so we got an a value of 3, which is a stretch. We have an h value of negative 3, which means I move 3 units to the right. Sorry, to the left. 3 units to the left. I got a k value of negative 4, which means I move 4 units down. And then for the x and y intercepts, you input 0 for 1, or you input 0 for y. Those end up being negative 13 thirds, comma 0 for the x-intercept, and for the y-intercept, it's 0, comma negative. Sorry, there's two x-intercepts for this one. Negative 5 thirds, comma 0 as well. And then for the y-intercept, that's where x is equal to 0. We get 3 times 3 minus 4, which gives me 0, comma 9. All right. Very similarly for this one, I'll just list out the transformations. You're on your own for the x and y intercepts. We got a is equal to negative 1, or actually the a value is 1/2, so that tells us that it's compressed. The negative tells us it's reflected. The positive 3 says we're going 3 units to the right, and the negative 1 says we're going 1 unit down. Talked about this one in class. This is actually this graph that's shifted down 4 units. We just need to make this part positive. Well, originally it would be this. In order to make everything positive, I just need to put an absolute value around it. All right, finding the different things for this. I'll do one of these, and then I'll just list out the other ones for you, like on the key. So for the x-intercept, remember, that's going to be whenever y is equal to 0. For the y-intercept, that's going to be whenever x is equal to 0. If we think about this function, drawing the graph is really going to help us. That's an absolute value function shifted 2 units left and 3 units down, which means that this function is increasing from the vertex to positive infinity, and we use the x values to talk about this, so we'll say from negative 2 up to infinity. And then we'll say it decreases from negative infinity up to negative 2. We don't include endpoints when we're talking about increase or decrease intervals. And then here you can see the function goes from negative 4 up to positive infinity. Okay, this one actually is a really cool graph. And what I recommended in class is find out where these two are equivalent, and you end up with this. You got the absolute value of x minus 3 equal to the absolute value of x plus 1. Graphically, what's going on, you have one of the graphs over here, and you have another graph over here. And you want to find those solutions. Well, to find the x-intercepts for this, we'll have to consider where the function is equal to 0. So we'll have to solve an absolute value equation, and that absolute value equation that we're solving is this one right here. So we'll solve it just like you did with the other ones. We'll split it up. X minus 3 is equal to x plus 1. X minus 3 is equal to the opposite of x plus 1. And very similarly for this, we'll find out where there's increasing, decreasing intervals, domain, range for all of these. So the domain should be evident, it's this. And then for the range of values, we'll talk about those too. You can look at the p-set for solutions for these prompts. Okay, then here, I'll do this one on the left. This one, to find the vertex, you have to do opposite of b over 2a, f of opposite of b over 2a. Or you can do complete the square. Just be careful, the completing the square is going to be challenging because a is not 1. Okay, the x-intercept for this. Well, that's whenever y is equal to 0, so now I'm solving this equation. I subtract 4. I divide by negative 2. I square root both sides, and I get x plus 1 is equal to plus or minus root 2, so x is equal to negative 1 plus or minus root 2. I don't have the room to write that, so you're going to write that up there. For the y-intercept, that's whenever x is 0, so that should be really easy to find. That's negative 2 plus 4 as positive 2. So 0, comma 2 here, and negative 1 plus or minus root 2, comma 0 there. Increasing intervals for this, if you remember parabolas, this one has a vertex up right there. That's where it changes from increasing to decreasing, and this parabola opens down. So it actually increases from negative infinity all the way up to the h value, and it decreases from the h value up to positive infinity. Domain, because it's a polynomial, is negative infinity to positive infinity. The range is the vertex value, the k, so the k value in this is 4, so this function is going to go from, whoops, no, I deleted it. It's going to go from, sorry, I can't bring that back, but it's going to go from negative infinity up to negative 4, and we're going to include negative 4. And then what was the last prompt on there? It was domain, range, vertex. The vertex is provided to us. It's negative 1 comma 4 because it's already in vertex form. And then for the axis of symmetry, make sure that you give me a line. That's a vertical line, x equals negative 1. Goes right through the vertex. All right, here we're asked to find the profit function. Well, remember that the profit function is revenue minus cost. They provided us with the revenue function and the price demand function, so all we have to do is multiply this by x, and that tells us how many items we sold, which is negative 2x squared plus 30x. Okay, so there's my revenue function. So now I'm going to take p of x equal to negative 2x squared plus 30x, and I'm going to subtract off 30 minus 2x. When I do that, I end up with negative 2x squared plus 28x minus 26. When I go and graph this, I'm going to recognize that it's a downward-facing parabola. This point right here, h comma k, that is going to be where the maximum or minimum occurs. It's going to be the maximum in this case because it's a parabola that opens down, and it ends up being a max at 7. And the price to charge per item, you're going to calculate p of 7. So p of 7, when I input that into my profit, or my price demand function, whoops, 2x, 2 times 7, that's 30 minus 14, which is $16. So I want to charge $16, and my break-even points, those are the x-intercepts, those occur at 1 and 13. And then finally, very similarly for this one, you want to figure out that vertex of the parabola. You can complete the square. You can use opposite of b over 2a. I don't care which way you do it. Just be careful because it's the number of time after 6 a.m., and so it occurs 64 degrees at 2 p.m. And there we go.